Alright, this video is going to look at different stretches and reflections of the parent function of the square root of x. So first we're going to predict the transformation, and then we're going to graph to check our result. Let's look at A. We have 5 times the square root of x. Basically, we square root x, and any value we get, we multiply it by 5. This 5 should stretch the graph by a factor of 5. Let's check by putting in some values. We are square rooting x first, so we want to pick some x values that have nice square roots, such as 0, 1, and 4. You could keep going with 9. Actually, I drew up to 9. Let's do 9. So the first one we have 5, I square root 0. So 5 times the square root of 0 is 0. That gives me the point 0, 0 on my graph. 5 times the square root of 1 is 5. That gives me the point 1, 5 on my graph. Notice this graph's already very tall, much taller than we've seen in previous graphs. Then I have 5 square root 4. Well, the square root of 4 is 2. 5 times 2 is 10. So I go 2 up 10. So I can't actually even fit this one on here. 9 is going to be 5 times the square root of 9, which is 5 times 3, which is 15. So that's going to be very high, like approximately around there. So we see that this graph still has a square root shape, but it's a really, really tall one. This has been a very stretched out square root function. So our prediction was correct. Let's look at the second one. We have g of x is negative square root of x. The negative should tell you it is a reflection, because any square root value of x is now multiplied by a negative value, so it should be down in quadrant 4. Quadrant 4. The fact that it's outside the square root tells me that it's a reflection over the x-axis. This contrasts with the reflection over the y-axis, which we will see later. So let's put in some values, such as 0, 1, 4, and 9. So the negative square root of 0, well, that's still 0. Negative 0 is still 0. Negative square root of 1 is negative 1. So I have the point 1, negative 1. Negative square root of 4 is negative 2. Because the square root of 4 is 2, then I make it negative. Then we have the negative square root of 9, so it's negative 3. So we go 9, negative 3. So this agrees with our prediction that it is a reflection over the x-axis. Previously it would have looked like this. Now it's been reflected in a mirror image over the x-axis. Let's look at C and D. So C and D show, C is a combination of A and B. So now the 5 stretches it and the negative reflects it. So it should be reflected over the x-axis and it should be stretched by a factor of 5. Let's plug in some values and see what we get. Like 0, 1, and 4. I don't think 9 is going to fit on there. So we have negative 5 square root 0. Well, negative 5 times 0 is still 0. I have negative 5 times the square root of 1. Well, the square root of 1 is 1 times negative 5 is negative 5. So my point is 1, negative 5. Then I have negative 5 square root of 4. Well, the square root of 4 is 2 times negative 5 is a negative 10. So I have 4, negative 10. And then I connect the points and we see it's not only stretched, but it's also reflected over the x-axis. It can be really nice to compare with our first two. It's really both of these together. It's both stretched and reflected. Stretched and reflected. Let's look at D. D is a little different. Now the negative is inside the square root. Whenever it's inside the square root, this tells me it is a reflection over the y-axis. So let's put in 0, but now I'm going to do something kind of crazy. I'm going to put in -1 because a -1 is a positive 1. And in fact, if I put a positive 1 in there, I would get an imaginary number because I cannot square root a negative number. So all of these values are going to end up being negative, which is why I drew the axes like this. So I can put in -1, I can put in -4, I can put in -9. The square root of -0 is still 0. The square root of -1 is the square root of positive 1, which is 1. The square root of -4 is the square root of 4, which is 2. The square root of -9 is the square root of 9, which is 3. So now you see why we had to do that with those values. I plot my points. And we see it is in fact a reflection over the y-axis, as our prediction showed us. Normally it would be over here, but I've reflected everything as if the y-axis were a mirror, and now it is growing to the negative quadrant 2 over here, in the second quadrant, growing to the left. So a nice challenge can be for you, try to graph what would be 5 times the square root of -x.